Welcome back to the DDI podcast. I'm Mark Yeeles, the Vice President for Schneider Electric's Secure Power Division here in the UK and Ireland. And in this season, we're bringing together leaders from across the tech ecosystem to demystify AI. My guest today is Tim Loake, Vice President of Infrastructure Solutions Group in the UK at Dell Technologies. And coming up in this episode,
AI is a plumbing problem. So liquid cooling has become a requirement for any of these high performance data centers of the future. To be successful in the tech industry today, it's no longer possible to be just a great relationship person. I think you need to understand what we're doing and you need to understand the technology. I think we have to think more carefully about how we manage our national grid infrastructure, how we price energy in the UK, and that will change the investment profile into this space in a dramatic fashion. And if you're looking for ways to kickstart the UK AI economy, that's the single biggest thing you could do.
So Tim, welcome to the podcast. Thank you, first of all, for taking the time out and joining me today.
Thanks, Mark. It's great to be here.
Well, let's get us started then. I'm always intrigued by first question, which is, you know, from your own standpoint and from you as a person, what was your career journey? How did you end up in Dell? And were there any? Was it a straight road, or maybe it might have been a bit curved? I don't know. Maybe you could share with us.
It's a good question. So I guess if I go all the way back to university days, I studied computing and management, and I've ended up working in computing, managing people. So I guess something worked there. But yeah, as you say, the path wasn't wasn't necessarily straight. So I spent a number of years straight out of uni as a systems engineer, designing and building large scale compute and storage systems across various different platforms. I was doing that for an industrial gas company, which was great. But I got to a point where I kind of felt like I'd outgrown what I could do in internal IT. And I went off and did some contracting for a couple of years, which was really interesting. Got to do some really fun projects, worked with a few friends of mine as well, which was nice. So that was all good. And actually, I was contracting when I came into Dell. So I got a call and and the interview was kind of interesting. So I remember talking to someone from Dell who ended up being my very first manager, and I spoke to them for probably 6 or 7 minutes on the phone, and 5 of those they were talking, and they said, "Look, this is the project we've got going on. We've got a few issues. We need somebody who has a bunch of technical skills," and I'd just come off a bunch of projects that were very, very similar to what they were looking at. And can you be in Watford on Monday? And I was like, yes, okay. And that was that. And so I came in to Dell to work on a project for a customer that was very challenged. We were deploying a bunch of kind of core infrastructure services across a VMware estate on PowerEdge 2850 servers. So the old 8th generation PowerEdge servers with a EMC storage backend. Roll forward nearly 10 years, and actually all 3 of those brands were together in one organization under Dell Technologies. So I kind of felt like I'd come full circle. But having started as a technologist to help fix a challenged project, I then ended up staying, which was never part of the plan. But Dell was setting up professional services, and that's what I've been doing for the last several years. And it felt like a natural evolution of what I've been doing to stay. And actually, I really liked the culture here. Dell always felt like it was and still does to some extent. It feels like a company where you're not necessarily part of a machine. You're able to design the machine as you go along. So if you see something that's broken, we're encouraged to go fix it. If you see something that needs doing or can generate value for a customer, go do it, right? And that's very much the culture that we have. And that's been something that's always really appealed to me. So I moved from service delivery into sales probably, 13, 14 years ago now, originally in services sales. And then I've been running the infrastructure business for the last 8 years for Dell in the UK. So today I lead all of our, what we call ISG, Infrastructure Solutions Group for the UK. So all of our servers, storage, networks, anything that our customers buy that could or should end up in a data center is my responsibility.
Wow. Well, I mean, what a journey. I'm not sure that was a straight road, in fairness. I mean, what I do
No.
love though is the university link to now. And
Yeah.
maybe there are a few steps in between, but very clear that there is some synergy between what you started with and where you are today. So fascinating stuff. I have a deeper question just on like today's world, and I'm always super interested in because you have a clearly you have a technical background, and I'm always fascinated by the barometer now of your workload, i.e., is it strategy? Is it people? Is it a combination of both? And where do you sit on the kind of swingometer between the two?
Wow. Listen. I think as any any leader at a large tech company will tell you, it's any given day you swing from one end to the other and back again several times. Um, I'd love my time to be spent on strategy and direction and market and where are we going tomorrow and all that kind of stuff. In reality, I think that's a relatively small piece of what I do. The bulk of what I do is solving problems for my team. It's getting stuck in when they get stuck. And I have a very capable team. So the things that they get stuck on are normally the really difficult problems. And whether that's problems that are Dell's to solve or our partners to solve or the customers to solve, actually identifying whose problem is it is a big piece of what I do. And then helping my team be successful, right? I'm not somebody typically who will, take stuff away, do it myself, and give it back fixed. I tend to help people go from where they are today to where they need to be, and knock the roadblocks out of the way for them. So, I think a lot of what I do is operational in nature. In all honesty, I definitely lean on my technical background a lot. I think to be successful in the tech industry today, it's no longer possible to be just a great relationship person, right? And I think you need to understand what we're doing and you need to understand the technology and be able to talk coherently and understand what customers are trying to achieve. And I think for me, that's always been a core of what I do. So I will never release that in terms of a skill set, but I've had to learn to deal with the softer side of the industry and managing people and dealing with the foibles of personalities as well. So, um, yeah, I think probably a bit of everything, but the bulk of what I do is quite tactical and operational in nature in terms of helping my team be successful. And I love spending time with customers. So, I try to make sure I see or speak to at least one customer every day. And normally that works out to somewhere between 6 and 10 customers a week. So yeah, it's good spending time with our customers and understanding what they are trying to achieve and using our technology for.
Thanks, Tim. I mean, that was a very comprehensive answer to the question of barometer and scale, just on the tech versus people piece. So, thank you for that. First of all,
Hmm.
I want to move us on next phase of the pod and just try and get your personal take on AI. Um, Now, from your perspective and what you learn, like you say, you're talking to customers every day. What kinds of challenges, barriers do you think there are for AI adoption, and how can organizations maybe understand or begin to extract value from the tech at a faster rate? How do you see that playing out?
So I think you have to separate out the market into those people who are already doing AI because they already had some of the fundamental pieces in place and or are building a platform for others to do AI on. And those people who are still, I'm going to call it stuck, but I'll come back to what stuck means in just a minute. So the parts of the market that are already moving and are already building out AI platforms, I think break down broadly into three subsets. So set one is research institutions, people who've evolved from HPC world, who understand large scale computing over multiple node architectures, who understand job schedulers, and really AI is a different type of workload, but it's the same underlying core infrastructure. So they're already set up to do that, and they've evolved into that space. And I think those organizations have the technology skills to do AI today, and we work with a number of them, and they're all good. You also have the algorithmic traders, the quant firms, some of the fintechs. Again, people who really understand the technology and have been working on complex multiple compute calculations for some time, and for whom AI is an evolution of where they are rather than necessarily a revolution. So they've started in a world of machine learning, and then they've evolved that and taken machine learning algorithms and evolved them into um, generative algorithms that can produce more data to help predict market outcomes and so on. So I think those two pieces are relatively well understood. And then you have the neo clouds, the tier two CSPs, all of those organizations trying to build a
Mhm.
platform upon which others will do AI. There are a lot of new companies in that space. There's also a lot of existing companies who've kind of evolved from the Bitcoin mining world into an AI platform world. And we work with many of those and help them build out their infrastructure. Again, very technically capable. And then none of those three really are beset with the two problems that are impacting everybody else. And so the two problems that I'm going to call it the enterprise faces, where people are stuck today, is at either end of the continuum. So they're either stuck um, in terms of identifying, quantifying, and writing a business case around the use case that they want to deliver. So, what outcome can I deliver for my organization, and what's the ROI going to be? So, I will invest X to deliver Y. Well, who's done this before? Nobody. So there is no benchmark, right? So actually quantifying your business case is really hard unless you stick to a business case that's easily quantifiable in terms of people savings or a process that you already understand the cost of that you can remove or automate or so on. So there's a whole piece of work for many organizations around the use cases in terms of identifying the feasibility of delivering that use case and the return on investment for doing so. And I think a lot of organizations are stuck there. Many of them are stuck with a big long list of ideas of things they'd love to do and not necessarily a good handle on which ones to do first or what the cost benefit is likely to be and how do they put that into a business case that either makes money or saves money. The other place people get stuck is I've got my use case, I'm ready to go, oh, my data is in a mess. And so I have my data is all over the place. Some of it's in public cloud, some of it's in SaaS platforms, some of it's on prem, some of it's with other third party service providers. And actually, to deliver the outcome that I'm looking for, aggregating and solving my data issue is a huge problem. And so, in my experience, enterprises typically are stuck in one of those two places with a side helping of those people who are sort of getting through those two, of people being stuck in, oh God, I now need infrastructure which I can't support in order to deliver this outcome. What do I do now? And they then become the natural customers for those neoclouds or for ourselves to go build them a new infrastructure to deliver that outcome.
And Tim, it's really interesting what you just prescribed to us there. And do you think if we fast forwarded the clock only, I don't know, 2 or 3 years, do you think all of those, I guess you called them a couple of case studies, there's a lot of don't know what we don't knows in there as well. Do you think a lot of those would have been surfaced and we'll see some momentum build like almost like an S curve of implementation as people learn faster and better?
Yes, some of the problems are easier to solve than others, right? So the use case problem actually is pretty straightforward because there
Mhm.
are a number of use cases, things that we've deployed inside Dell Technologies and we've seen deployed for some of our customers, which actually can be applied to almost any industry and can deliver real benefit. And I think increasingly everyone will get to understand what the savings or uh, revenue increments will be from those standardized use cases, and that becomes your starting point. And those starting points actually then help you build out targeted landing zones for your next projects, which might be even more customized or unique to your business, but
Mhm.
you'll end up with, I think most organizations will end up with pods of infrastructure to support different types of AI workloads. So maybe you'll have
Mm.
a small language model pod or an agentic pod or a
Uh-huh.
machine learning pod. And depending on the type of workload that you need to deploy, whether you're training, fine tuning, inferencing, and in what way, you will deploy it onto different landing zones of infrastructure, which is exactly how standardized IT has been for however many years, right? We all had a virtualization platform and we had a database platform and a whatever else, right? And so we're used to designing infrastructure in that way. I just don't think we necessarily know what those template reference designs need to be yet from an AI point of view. Well, for
Very
2 or 3 years, we'll get there, right? So,
Yeah, got
so
it.
the landing zones will be defined and well understood, and actually, the use cases for things like multilingual chatbots, digital humans, customer engagement tools, effectively, coding assistants, document repository. There's various different ones that you can say, actually, we know how to quantify and define the benefit of that. And so those become the starters that most people will deploy relatively quickly. And then on top of that, you'll then deploy the more business specific things.
Got it.
Maybe it's claims management in an insurance context or whatever it might be. And
Uh-huh.
so those will sit then as a next wave of implementation behind that.
Fascinating stuff. And when I think about and the conversations I've been having with clients across the industry, there's a number of different ecosystem challenges, and I guess one of the ones that I'd like to address with you now is, how can we meet, AI, economic, and sustainability ambitions together, and could building out large data centers actually together with renewable energy be a catalyst for change? And do we have the right do we have the right kind of infrastructure today to serve that demand? And if we don't, what could that look like? That's
Yeah.
an easy
So,
question, isn't it?
well, it is and it isn't, right? It's funny if you look back at any of the big HPC or supercomputing conferences over the last 2 years, they really changed focus. So roll back to well, I guess in 2022 we didn't really have any of the supercomputing conferences because of COVID, but pre 23, actually those conferences were all about performance, silicon, how to optimize your model and your code, and really not a lot else, right? And they were relatively modest in size, a couple of thousand people who were working
Mhm.
specifically in that space. Roll forward to 2023 and 2024, whether it's ISC in Hamburg or Supercompute, which obviously moves around the US, or any of the others, CIUK, they've become plumbing and heating conferences, right? AI and its impact on infrastructure. AI is a plumbing
Yeah.
problem. And because with the increase in size and physical size of silicon, the increase in power throughput in that silicon and subsequent heat generated as a result of pushing that much power through that many transistors in that smaller space, we're breaching through the limits of what air cooling can deliver on a daily basis in terms of the silicon advancements. And so liquid cooling has become a requirement for any of these high performance data centers of the
Sure.
future. Um, and that requires a very different paradigm. If you think a typical hoster, or let's take a typical colo in the UK, you can specify for low power consumption anywhere from 2 to 5, or low density 2 to 5 kilowatts a rack. Well, I have plenty of servers now that will do 5 kilowatts of consumption in a single server, right? Just straight off the shelf. Um, if you go medium power consumption, you're anywhere from 5 to 15, and then high density is 20 to 50 kilowatts. That's pretty standard across the UK industry. And so those high density racks are few and far between. But I can tell you, if I take a 9680, even with H100 cards, those today will pull 12 kilowatts a server. So I know the highest density rack you can get in one of today's air cooled colos is 50 kilowatts. You can put 4 in a rack, right? Which means you're just over half full and you consume the entire power budget for that rack. And most of those facilities can't take very many of those racks. So going beyond that becomes a very different problem from a power density point of view. And if you're going to put more power density, you're going to need to cool it differently. And so we have to get over the hump of new data center infrastructure that massively and dramatically increases our power density and our cooling capability as part of that. So, if I think about what we're shipping now, our GB200 racks are close to 140 kilowatts a rack, fully populated, and they will they will spike beyond that, right? So there are some interesting nuances when you're checkpointing large AI jobs on Blackwell GPUs in terms of power spikes. And while you can mitigate those in software, actually the spikes are still there if you're running at full performance. Um, and as we look ahead to future platforms, we already have racks we can configure today that will be 200 kilowatts plus a rack. And within a year's time, we'll be seeing 500 kilowatts a rack and beyond. So that's 10 times the power density that the vast majority of data centers can deliver today. And we haven't even looked at how we cool that. So um, I think to go to your question of are we equipped today to handle the workloads of the future, the answer is no. We're going to need new facilities or dramatic refits of existing facilities, and we're going to need to start building data centers close to where the power is, because you don't want to be transmitting huge amounts of power across large distances. Floor space is no longer your constraining factor. Your constraining factor is the amount of power you can deliver per meter squared, not the number of meters squared that you have. And so actually, I think you'll see data centers getting smaller and denser. They'll become more distributed close to where the power and connectivity is, rather than
Mhm.
necessarily large scale mega data centers. Although sovereign AI will probably drive a few of those, and we'll
Mhm.
see governments investing in you know, very large DCs as kind of consolidation points. And there'll be at point places around different regions. And we've seen the French government moving
Yep.
in that direction, as well as the UK government as well, with the AI growth zone concept. But for most organizations, actually, I think the future is likely to be physically smaller, but very high dense power
Power use.
consumption and power use. Thank you. Rather than um, very large mega data centers. When you go to that model, you then have new opportunities that open to you around how you do things like heat reuse, right? Whether that's for
Of course.
municipal facilities or district heating zones or whatever it might be. There's a whole new paradigm that you can take that waste heat, because you've got the heat captured in the liquid. It makes it much easier to transport than when it's air in an air format. So I can transport it to somewhere and put heat generators next to heat consumers, and actually you can create a much more viable, sustainable future, um, which becomes almost imperative when you think about the power consumption that's going to be needed to drive some of these data centers in the future. So to go full circle back to the sustainability point, I think we'll see smaller, modular, high power data producers or energy consumers and heat producers, I should say, next to heat consumers, whether that is people's homes, swimming pools, council facilities, or some other heat consumer there.
Fascinating. Thank you for the in-depth view on this. I mean, there are a number of different challenge areas, as you mentioned there. There's a geography piece, there's a power availability piece, there's a how do we liquid cool these damn things, yeah, all of which are being solved for at this moment in time, of course. And we're doing our own work on this at Schneider Electric, just on the cooling in particular, which we see it's almost the fastest growing part of a data center in terms of the technology outside of the chip, of course. Now, you mentioned something earlier which sparked my interest. AI is a plumbing problem. I mean, I never thought I'd hear this kind of phrase, but I'm all ears. It is a challenge. The industry and other industries in the UK have this opportunity stroke challenge with people with the right skill sets in the right areas. What's your kind of view here? Is it a problem, or do we think we just got to pivot a bit?
I think it's a skills problem.
Mm,
Personally, we are not turning out, and we haven't been for a long time. And I'm going to speak UK specific, right? Because
sure.
my remit is the UK. It's the market that I know and understand well, and so I'm going to look at the UK. But we're not turning out enough engineers. We're not turning out enough either mechanical engineers or electrical engineers to cope with the demand that's going to be required as we reach this inflection point, right? We've gone actually from an a mechanical electrical point of view, we've gone from relative stability over the last kind of 10 years in terms of the technologies involved. There've been evolutions, but certainly no revolutions. But we're now at a massive inflection point. To your point, this is a change curve that is um, quite dramatic from a data center industry perspective. And if you think about the knock-on impact of, for example, going down the heat reuse road, actually that changes how you need to think about building new homes and building new facilities to take a mixed heat source. So to take a heat source, because you can't just turn, if you're using, for example, a block of flats with a district heating system as one of your consumers of the heat from your data center, just because it's summertime doesn't mean you don't need to get rid of the heat. So somewhere on the line, you still have to get rid of the heat from your data center, right? And so we need to have the ability to flex that on and off. And also, if it's really cold in the winter, maybe your data center's not enough heat, and you need to have ways of supplementing that with existing systems. So there's this whole kind of balancing that will need to be done, because typically data centers run hot all the time, right? They generate heat on a pretty consistent basis because we've gotten quite good at balancing our workload so that our systems all run at about the same level. And particularly with AI, if you're running large training jobs, they're just maxed out the whole time. So you're going to be producing heat a lot of the time. But as humans, we don't necessarily, certainly living in the UK temperate climate, we don't necessarily need heat added all the time, right? Our heat requirements go up and down, whether we're at home or not, and whether it's hot outside or cold outside, and whether it's raining, and all those different factors. And so, um, taking a fairly static and predictable producer and marrying it up with a very variable consumer is not a straightforward thing. And I think we have, as a nation, we have a skills problem. I think we have an opportunity to fix that, because I think there are smart people and there are lots of smart kids, and if we can encourage them to go in the right direction. My my eldest is 17, and we're having these conversations at home right now about what he does
You're
with his
living it.
time. There are lots of options out there, but I don't think we're well equipped from a skills perspective to be able to deal with the challenge that frankly is upon us over the next 10 to 15, maybe even 20 years.
Yeah, Tim, I think you made a really good point there, and I've seen it in other industries as well. Even I don't mean even, but very similar in the water industry, for example. There are big
Yeah.
investment cycles, and the skills that there are companies there that are very skillful, but it's just the volume of people needed to execute on that capital investment that's been a problem for a number of years for that particular industry. So more food for thought for us just on that. You mentioned earlier, Tim, well, in very brief term, you said about the AI growth zones. Um, and as the government starts to build out its plans, started to invest into AI, how can we balance the kind of development of those growth zones with the energy and sustainability concerns? I guess it weaves into a previous question, really, but it's more, how do we geographically, how do we think about this, maybe in a smarter way?
Well, at the risk of trying to tell our government what they should and shouldn't do, which isn't necessarily my responsibility, um, I do think the UK would be far better off if we could move to regionalized energy pricing, and I think it would dramatically change the profile of investment in the UK, in terms of the future of these AI growth zones and private investment into data center space. So, and I'll give you a couple of examples to illustrate the point.
Mm.
Scotland currently has 5 gigawatts of excess energy capacity, but the national grid does not have the infrastructure to get that power out of Scotland and into southern England where it's needed. So today, what do? We turn off the turbines, right? We slow the progress of the water through the hydroelectric turbines, and we turn off the wind turbines, so we stop generating. So we have a renewable source with plenty of capacity that we could do something with, but we can't transport it. And at the moment, consuming it in Scotland is exactly the same price as consuming it in central London, because we have nationalised energy per unit pricing, which means that it doesn't get used there either. because it's not economically viable to do so. So we turn off the production of our um, green renewable energy, and we rely on either imported nuclear from France or gas or whatever in terms of other sources to feed southern England. If you were to move the UK and take the 14 national grid energy regions that exist today and simply let them price locally, the expectation is actually everybody's energy price would go down because you wouldn't be pricing to the lowest common denominator. Even the most expensive zone would still come down slightly. Um, and Scotland specifically would end up moving from roughly 15 pence a kilowatt for commercial power consumption to circa 4 or 5 pence a kilowatt. Oh, sorry, yeah, kilowatt hour, which is equivalent to the Nordics, which is currently Norway, Sweden, and even Finland are picking up all of the investment for the vast majority of Europe because they have renewable power availability at a reasonable price. Well, their pricing is the same as Scotland would be if you were to turn off or to move to regional power. That would bring inward investment into the UK from all of these companies who don't really want their stuff sitting in Norway, Sweden, or Finland. They'd rather have it in the UK because many of them are UK headquartered. And the UK brings a number of financial benefits in other ways. But today, the energy pricing makes it unviable. And so I think we have to think more carefully about how we manage our national grid infrastructure, how we price energy in the UK, and that will change the investment profile into this space from private industry in a dramatic fashion. And if you're looking for ways to kickstart the UK AI economy, that's the single biggest thing you could do. And actually, I think you need an awful lot of builders, electricians, mechanical engineers, and so on in
Plumbers,
Scotland to
plumbers.
build data centers really, really fast. Plumbers, yes. Um, AI is a plumbing problem, and you would need those people there to build out data centers to cope with that demand at ridiculous speed. The National Grid are working on the transport infrastructure. They're working on how to do that. We've just seen the first substantial grid battery bank open. So
Mhm.
there's things we're doing to help consume some of that renewable power so it's not wasted by just turning off the turbines. But fundamentally, the single biggest thing they could do is start to deregulate our power pricing. And that will be good for consumers, good for inward investment into the UK. I don't really see anybody loses, in all honesty, but I don't make policy.
Well, that's a very good insight for somebody who doesn't make policy. So I appreciate that, and it's a fascinating topic, isn't it? Because naturally, an organisation like Schneider Electric is also looking for that regionalisation of investment and where it's coming from. We have seen a bit of a shift. I mean, there's no doubt about it from a but maybe more driven from the availability of power, not necessarily the cost profile of it, like you just explained there. So I think we would see that change. But I'm gonna hold that thought and then maybe pivot us onto another topic here, which is um, how do we, how do you and how do Dell see the future heading, and how will AI benefit more broadly society? And because AI is it's a juggernaut of PR. And I think a lot of people see AI and think, "Oh, geez, that's robots taking over the world." Um, how do you see that? What does that benefit to society look like from yours and Dell's perspective?
For us, it's productivity. We you see, there's been a lot of stuff in the press recently around UK productivity per capita, GDP per capita, and that being a core defining metric of whether a country prospers or not.
Hmm.
Well, AI is a way of dramatically improving our productivity on an individual basis. And we've seen that inside Dell. So I'll give you a couple of examples. So we have rolled out a coding assistant for all of our developers. And we have thousands of developers developing all the software for all of our products. That coding assistant has started creating pretty much 80% of the code base now. So we trained it on all of our existing knowledge and all of our existing code. So it knows how Dell writes code and all of the features of all of our existing products. And now it helps all of our developers code faster. So we can get features to market, we can get fixes completed in a far faster time frame than we ever could
Mm.
before. And so we're
Mhm.
seeing all of our product roadmaps come in versus what,
Interesting.
when we wrote the roadmaps, we defined them based on what a human could do in a certain amount of time, not what a human plus an AI
Right.
can do. And so we're seeing our release dates come forward time and time again. So every week I'm getting notifications saying, oh, this date's come forward by a month and this date's come forward by a few weeks or whatever it might be. And so
Wow.
things that I was expecting to see in the latter half of this year, we're going to see, in the early summer. We've got features that we were talking about releasing in May and June coming forward to this month. And so the productivity of our team is huge and hugely improved. So that's that's one example. From a sales team perspective, if I think about my own personal experience and my team, we now have a sales chat. Essentially, it's a chatbot that's been trained on all of our gold standard marketing content, all of our presentations. It has access to all of our customer data. And so you can say, I'm going to a meeting with Mark from Schneider Electric. I want to talk to Mark about AI. Please write an introduction mail for me um, to precondition the meeting with Mark, produce me a slide pack that I can use to drive the conversation with him and give me a suggested talk track of that conversation. And it will work its way through and produce all of that for you. So my meeting prep time has gone from, potentially a couple of hours to 10, 20 minutes. And that's mostly reading stuff that's been produced, editing, changing, adjusting, and working out how I want to change the conversation. But it's remarkable the productivity improvements that we're seeing, and that's only been live for a month, and it's scary how effective it is.
Wow. Well, thank you for those examples. And I think there are many, many more across many other sectors as well, in particular in maybe healthcare, fintech as other examples as well. I'm sure there's many we could share. Um, I actually want to circle right the way back round to the start now, actually. And with all of this conversation that we've had today and all the experience that you've gained on that windy road to lead the team today, I normally do a bit of future gazing, but I'm going to kind of change it up a little bit and ask you, um, what piece of advice would you offer to somebody entering this sector now? Appreciating that it's there's an exponential growth in a number of different areas, topics, but how would you advise someone? I'm intrigued.
So I do this on a regular basis, right? So I do a
Great.
whole bunch of mentoring with people new to the company, as part of our Gen Next employee resource group and so on. So I have these conversations on a regular basis, and the talk track varies by individual, but actually the content is largely the same. So um, AI will reduce the need for people to have knowledge. It does not reduce the need for people to have skills. And so as you think about, as young people enter the workplace or consider their um, university choices, in the case of my son or whatever it might be, I'm encouraging them to think about what skills can I develop, what abilities can I have, rather than what knowledge can I learn. Because AI will supplement our knowledge. It will feed us information at the right time to have the right conversation or to do the job in a way that you can't possibly hope to learn without many, many years of study. And by the time you've learnt it, you're out of date. So we no longer need to educate ourselves in the way of learning knowledge. What we need to do is learn skills and have capability. And from what do I think are the skills that are new that we're likely to need? Data science is an obvious one. People who can understand and interrogate data and help our models do the right thing with data. Obviously, prompt engineering, how to get the best out of your AI assistant, whatever that might look like,
Mhm.
I think that needs to be a core skill in the very near future that's taught in schools.
Mm.
And also anything that is skills based, right? We've talked about AI being a plumbing problem. It's also an electrical problem. It's also a a physical engineering problem. There's a whole bunch of core skills amongst in that kind of mechanical electrical space. That's not going to be replaced by AI anytime soon, right? And actually, that becomes fundamental to how AI operates or doesn't, right? So the challenges are going to be very much in that space. And so I think it's important that we teach our children, our young people, to be curious, to ask questions, and how to get the best out of the knowledge repositories that will exist and be at their fingertips, in a way that you and I certainly never had when we were growing up, and we're having to adapt to as probably somewhere around about or just above the median working age in the UK. We're having to learn on the job, but young people coming through now, they have the ability to pick this stuff up and go far further than we ever will be able to. But it becomes a conversation about skill, not knowledge.
Conversation about skill and not knowledge. I love that. And I love it for a number of reasons, because it gives some real insight into the new learning environment that young people are coming into. So you're right. There's, the role of the encyclopedia, which I used to spend some time reading, is now at our fingertips, at ease. And it's an encyclopedia that's probably grown by 10-fold, 20-fold, 30-fold, 100-fold, who knows? I love that, and the way that you and Dell are thinking about the way that we shape this industry is commendable, and we look forward to being part of that journey too. So, Tim, we've gone full circle. We learnt about you at the start, and we've learnt about what you're teaching and mentoring for our early talents coming through into this industry of the future. So, thank you for your time today. I really do appreciate it.
Thanks, Mark. It's been great. Really enjoyed it.